Okay, so let's take a look at the Tune Model Hyperparameters pill. And let's say we're working with the bike buyer's numeric data. So I've got a number of columns in here. We can do a real quick look at the data set. You can see we've got marital status, gender, marital status numeric, gender numeric. So we've got a variety of fields that are categorical and that have been transformed to numeric versions of those categorical fields as well. Income, children, education, numeric, commute distance, number of cars, age. And then what we're trying to do is predict, is this consumer likely to buy a bike? So first we want to determine, well, which fields have we duplicated with numeric? We can filter those out. So if we do the select columns in dataset, well, we've already excluded column ID. So let's go to the column selector and see what other column names we want to exclude. So ID, marital status numeric, gender numeric, education numeric, homeowner numeric, and of course, purchase bike numeric. All right, so we'll filter those out. The ID, not necessarily because it's a numeric version of a field we already have, but because the ID isn't really something that's going to be a good predictor for us. All right, so we filter that out, going to clean the missing data and normalize the data. Of course, depending on what we're trying to do, we may or may not need to do this. And at this point, I can say, well, let's go ahead and build a model. Now, the Tune Model Hyperparameters pill lets us take two different approaches here. The first approach, I can actually just, and I'm going to pull it in right now, Tune Model Hyperparameters. The first approach, I can basically just say, I want my data to go in here, and I'm going to bring it into the middle port here for my training data set, and then I can choose which type of model I'd like to build. So in this case, let's say I want to use a support vector machine. So we have a 2-class support vector machine, and I connect that. Okay. Now the Tune Model Hyperparameters, in this case, I can say, well, I want to go ahead and instead of doing the entire sweep, a random sweep, I can tell it to do the entire grid. And that's going to allow it to choose all the different combinations in a structured manner of all the parameters we can use. So random sweep isn't a bad place to start. You can also do a random grid as well and tell it how many iterations to go through. So it initially starts us off with 5. And that's not a bad place to start. Now, if we are using a classification model, we want to use one of these types of scoring mechanisms to determine how well our model's performing. Accuracy is a place to start, but we prefer AUC in this class, area under the curve. So we'll choose that. So the model hyperparameter tuning is going to work itself to the best solution using AUC. Now, at the same time, I need to go to my technique here and choose how I want to train. So I can train on a single parameter, but I want to go ahead and let it go through a parameter range. And I'll click the Use Range Builder for all the options I have available, so the Tune Model Hyperparameter will be able to work its way through the different ranges. And I'll just leave the parameter ranges at their defaults for now. At this point, I'm allowing the Tune Model Hyperparameter to act as my model training tool, and then I can take the output of that and score my model. So score. So I'll score the model that comes out. That will be this port here, my trained best model, and that goes into this port. And then I'll repeat the normalized data going in for my data set. And at that point, I can evaluate the model. Also, don't forget when you are tuning your model hyperparameters, in this case, using the model, or in this case, using it to train the model, you have to also indicate which label value you're going to be using. So the label for us is going to be purchased bike. All right. So I click OK. And at this point, I'm ready to run. Now you can see here I'm using the full data set. I could also do a split right here and train on the 70% and use holdout for the remaining data. And that would definitely be better practice. So I'm going to go ahead and do that. Split data. And the initial result goes in here. The holdout goes there. And I'm now good to go. And I'll go with 70, 30. Okay. So I now have my split data. I'm going to tune my model hyperparameters based on a random sweep with 5 iterations. My support vector machine I have set up to allow for a parameter range running through the Tune Model Hyperparameters. Then I can score my model and evaluate my model. The other way we can do this is we can also do a full cross-validation. So what I'll do is I'll bring my partition and split, or partition and sample, just like I would normally do. And as long as I have the cross-validate model, I'm going to bring it in because I'm going to use it as well. So the partition and sample says, well, first we're going to say I want to assign to folds. It defaults to 5, but we're going to change that to 10. And we don't need to worry about stratified in this particular case. I'm going to partition evenly. So I'm good to go there. I'm going to create another branch over here on the right for my approach with cross-validation. I'll bring in my support vector machine one more time. I'll set my Tune Model Hyperparameters. So the model, I'll go ahead and switch these over. The model goes in here on the left. My results data set is going to go in here. And I have copied this support vector machine. I want to double check, and yeah, I do have the parameter range, and I've got the use range builders selected so that it's going to allow the hyperparameters to vary. I've got the partition and sample coming in here to set up and tune my model hyperparameters. And I'm going to, in my model hyperparameters, have the sweep results, but I'm more interested in the trained data set, which is going to go into my, my trained model, which is going to go into my cross-validate model. And then my partition and sample data set also becomes the input for the cross-validation data. All right. So I'm going to cross-validate the model. Now, because cross-validation is going to score my model automatically, I don't have to add the score model, and I'll just take these scored results and I can bring those into my evaluate model as well. And at that point, I can go ahead and run everything. Whoops, no, I can't because I have not set my label column in the cross-validate, so I need to do that there as well. And my purchased bike again will be my label. And at that point, I am ready to go. So let's run this. Okay, and in this case, you can see it ran in about 3.5 minutes. And that was with 5 options here, or 5 iterations of both Tune Model Hyperparameters and cross-validation over in this side. That's with a bike buyer's data set that has about 1,000 rows. So one of the things about Tune Model Hyperparameters is I can now look at my sweep results to see how the model got better with each iteration. So here I can see my AUC went from 6.35896 to 6.47. So as a matter of fact, it was pretty consistent there for a while, and then we did get a little bit of a jump. All right, 0.64. So more than 1% improvement there. Let's see what we got on the other side. And in this case, we had AUC from 6.33, and it stayed pretty steady all the way through. Now, in this case, we're using all the data, whereas with split data, we get a little bit less representative results. So we can now evaluate our models and see how they did side by side. And we could see the first model gives us an AUC of 6.05. And the second one gives us 6.633 once we have the scored data set. So the cross-validation was able to do a little bit of additional work. And we could see in the cross-validation that there's a fairly decent range of AUCs with an average of 0.633 here. And if we just look at accuracy, it ranges from 0.53 all the way up through 0.66, it looks like, is our best. So a little bit of a range. So that might mean that we want to go back and let's retune these model hyperparameters and let them run the entire grid. Or I could say, let's give it a few more random sweeps. But if I run through the entire grid, it's going to actually give me my best solution. Now, the downside is that means it's going to also take longer. All right. So I'm going to turn entire grid back on and let's see how long it takes to run. And this will give you some ideas for planning purposes, how to approach using these tools. So I'll now run selected and it will recognize that we've already run the steps leading up to Tune Model Hyperparameters. So it should pick up right there and get going from that point forward. So here we are at 10 seconds. Let's see how things go. And here we can see that the runtime increases to about 7 minutes when we search for the entire grid on both of our Tune Model Hyperparameters. Now, the results when you change the options from a quick sweep, random sweep with a limit on the numbers to the entire grid is going to vary depending on both the size of your data set, the number of features in your data set, and the number of range builder options and parameters that can be tweaked in the modeling technique you happen to be using. So in this case, it went from 3 minutes up to about 7 minutes. It could for others, quadruple or even increase even more in runtime. So just keep that in mind as you think about ways to use the tuning techniques to help squeeze that last little bit of performance out of your model. We can see here that if we evaluate the models, let's see what happens. So we can see the AUC for the left-hand side is at 0.609, 0.634. So not a ton of improvement there, a little tiny bit, I think. And then we can also see what happened when we were tuning the hyperparameters, the sweep results. Obviously, we have more iterations with the sweep, but we can see as we get a little bit better performance, it's maybe going up incrementally, but this many iterations, and you can actually see how many iterations it has, and we have just a tiny bit of performance from the original runs all the way up through these latest runs. All right, so hopefully that gives you a feel for how Tune Model Hyperparameters works and how you might be able to make use of it in your modeling efforts.